Okay, so our problem is 560. Let's read the question first. Determine the magnitude and the direction theta of the maximum force P needed to pull, minimum force P needed to pull the 50-kilogram roller over the smooth step. Now we have a force P acting on the structure, and certainly we have some forces. First of all, we have the weight, and there exists a force coming from the step. Now, there is a critical point. Of course, there is another reaction force at A, but the thing is this. Remember that these are contact forces. So the forces at A and B are contact forces. Therefore, they are perpendicular to the tangent of the surface. Now, the thing is this. Just imagine that you are pulling this roller and it hits this step. Now, there is an instant, okay, when it hits, certainly it will stop. And at that moment, just think that you stop and begin to increase the force P gradually. So step by step, small, very small steps. And the point is this, there is a certain instant that this roller will move on the step. At that instant, if you freeze everything, so instantaneously, the contact between this inclination and the roller will be lost. So at that moment, the force at A is lost. Therefore, we are left with the contact force at point B, acting on point B, and weight and force P. Okay, so let's draw the free body diagram. Now, this is our inclination. Certainly, we can choose coordinate system. In this question, there are two possibilities. One is to use the classical coordinate system. So we can choose the horizontal axis as X and vertical axis as Y. And there is another possibility. Certainly, we can choose another coordinate system. In this coordinate system, of course, x-axis will be parallel to the inclined surface and y-axis will be perpendicular to it. This is the other possibility. Certainly, both solutions shall give you identical results, same result, by means of magnitude. Okay, so basically, I will choose horizontal axis as x and vertical axis as y. And I will write the forces. So I have the weight. Remember that this angle is theta 1. As a result, this angle is theta 1, 2. Okay. Now, if this is theta 1, and there is an angle of 90 degrees, certainly this angle is theta 1, 2, this angle. Now, of course, this angle is given by the problem, it is theta. Now, as I said, contact force FB is perpendicular to the tangent of the surface at the point of contact. So this angle is 90 degrees. Certainly, FB is a vector. So it is better to draw an arrow on it. Okay. So these are my forces. As I said, this is θ1. This angle is θ1. This is phi. If this is phi, this is theta. If this is θ1, so this is angle is also θ1. Now let's write the forces in Cartesian form. This will be the next thing that I'm going to do. Now, first begin by P. P is equal to P times, P here is the magnitude, if I don't put an arrow on it, P cosine theta plus θ1. So because this angle is theta and this angle is θ1, therefore the total angle is theta plus θ1. Therefore, in fact, x component is P times cosine theta plus θ1, and y component is sine theta plus θ1. So it is P times cosine theta plus θ1 I vector plus P times sine theta plus θ1 j vector. Now the weight is downwards. It is in negative y direction. So it is negative wj, and w is mass times gravitational acceleration. Gravitational acceleration is considered to be 9.81 meter per second square. Now FB. Now, if this angle is θ1, if this is phi, certainly x component is FB multiplied by θ1 plus phi, and it is in minus, so it is FB multiplied by sine θ1 plus phi, I vector, plus FB, this is the y component, FB multiplied by cosine θ1 plus phi, j vector. Now let's write the sum of the forces in x direction. We will write the equilibrium equations. Of course, in x direction, we have P cosine theta plus θ1 minus FB sin phi plus θ1, and this has to be equal to 0. In y direction, it is P times sine theta plus θ1 plus FB cosine phi plus θ1 minus W is equal to, has to be equal to 0. This is my second equation. Now, the third equation is equilibrium, so the moment, sum of the moments with respect to any point has to be equal to 0 for the rigid body equilibrium, for equilibrium. In fact, I can choose any point, but the reasonable choice is the point B in this case. So I choose point B, and I will calculate the moment with respect to point B. As a result, I need this component of W. Now remember that this angle is θ1 and this angle is phi. Therefore, this component of the W is W multiplied by sine θ1 plus phi multiplied by the radius, and remember that the radius is a. Okay. As a result, it is minus W sine θ1 plus phi multiplied by a. Now, next thing is the force P. I will calculate the P, moment generated by force P. Now, I need to calculate this component. So this is perpendicular. Now here, as you see, this angle is 90 degrees. As a result, this angle is equal to P divided by 2 minus phi. And in fact, I need to know this angle. Therefore, this angle is P divided by 2 minus phi plus theta. And if I multiply the magnitude of the P with sine P divided by 2 minus phi plus theta, I will get this component of the force P. No, I'm sorry. Okay, so now P multiplied by sin P divided by 2 minus phi plus theta multiplied by A minus W sin theta 1 plus phi. Now I need to calculate the phi. Okay, this will be the second thing, because theta 1 is given, theta is unknown, P is unknown, FB is unknown, and I have to calculate the phi. Now I know that the radius is here denoted as 0.6 and denoted with A. Okay, and B is 0. Sorry, this is 0.1. Please correct it. This is the step length. Or let's write it like this. It is 0.1. B is equal to 0.1 meters. Okay, so let me do it in a better way. It is 0.1 meters. And let's close it. That's, yeah. B is equal to 0.1 meters, A is equal to 0.6 meters. And in fact, from here, I can calculate the L. L is the distance between the step length and this axis. So it is this length. So just think that these two lines are parallel. This is the L. Now I can calculate the L as 0.33 meters. Don't forget the units as I did. So of course, this is 0.6 meters. So from here, you can calculate the L. So simply it is A square minus A minus B square, and that's equal to 0.33 meters. From here, I can calculate the phi. It is arctangent L divided by A minus B. So it is this length divided by this length. let me draw the triangle here. So this length is a minus b, this length is L. L divided by a minus b will give me the tangent phi, phi. So I can calculate the arctangent of it, and I will find 33.55 degrees. Now I know the phi, and certainly I can put it into these equations. Now I have three equations, as you see. So 1, 2, and 3, and I have three unknowns. I have P, theta, and FB as unknown. Okay, so by doing some algebra, I will not get into that one. You can solve these three equations, and in fact, you will find two different results. The first one is P is equal to 804.691 newtons. We have to write the units. And FB will be 992.673 newtons. And theta will be 152.921 degrees. Of course, this means that so this solution is not acceptable, because these two solutions are identical, but the point is how you apply the force. So basically, in the first one, you are pushing the roller, and certainly our solution is the second one. So theta is equal to 804.691 newtons, and FB is 992.673 newtons. And theta is equal to minus 27.079 degrees. So this is not acceptable for us. Therefore, it's not our solution. So the second one is the solution of the problem. This is the solution. Sorry, let me close it better way. Yeah. Okay. So this is the solution. P is 804.691 newtons, FB is 992 newtons, and theta is minus 27.079 newtons.